Welcome students, welcome to AIPMT 2016 solutions by Nivedita Classes. Now we will discuss question number 20 of subject physics from code Z. What our question says that two non-mixing liquids of density rho and n rho are put in a container, and it is given to us that n is greater than 1, so the density n rho will be higher than the density rho. Height of each of the liquid is h. So let's first draw what is given to us, that we are given with a container, and assume that this is our container, and in this two liquids, both up to height h. So this first liquid has a height h, the second liquid it also has a height h, and here the density is rho, and in the lower liquid the density will be equal to n rho. A solid cylinder of length L and density D is put in this container. The cylinder floats with its axis vertical and length PL, where P is less than 1, in the denser liquid. So what's given to us that let's say this is our solid cylinder. This is our solid cylinder, and this solid cylinder has total length of L, of length capital L. Now PL, this length is inside the denser liquid, and remaining length, what will be the remaining length? The length will be L minus PL, so that will be 1 minus P multiplied by L is in the other liquid. Okay. So now we have to find that what is the value of density D. So what will be the downward forces and what will be the upward forces? If we find out, the downward force will be equal to its own weight, which is mg. So let us say the downward force will be equal to mg. Okay, mg will be the downward force, mg. Okay, where m is the mass of the cylinder. Okay, if I convert it into volume multiplied by density, so we will have V D into G, and let's say that it has it is a cylinder and it has its flat area as capital A, so it will be equal to LA, that will be the volume, into DG. Okay. So this will be the downward force. What will be the buoyant force? That will be upward, and both will be equal. That's why this cylinder is floating. Clear? The buoyant force will be due to both. Let's say here you have buoyant force due to downward part, and then we have buoyant force due to upward part. So let us say for the downward part we have buoyant force as FB1, and for upward part we have buoyant force FB2. Okay, and the buoyant force will be equal to the weight of the liquid which has been displaced. So the lower part volume, if I find out, let's say it is equal to V1, and what will be the density? Density is N rho. This is the mass multiplied by G plus V2 rho G. Okay, so let's find out what is V1 and what is V2. So if I talk about V1, V1 is equal to PLA, and V2 is equal to 1 minus P multiplied by L multiplied by A. Let's now equate FB and mg and put the value of V1 and V2. Okay, so first is PL A N rho G, okay, plus 1 minus P multiplied by L A rho G. This is equal to L A D G. So first cancel out the commons. G is cancelled out, L that's also gets cancelled out, and A also gets cancelled out. Now what we are left with? We are left with P n row plus 1 minus P multiplied by rho, okay, and this is equal to D. If I rearrange and take the row common, so it will be rho outside, then we have P n plus 1 minus P, which can be also written as 1 plus n minus 1 into P. This will be equal to the density which we have been asked for. So rho multiplied by 1 plus n minus 1 into P, which is our option number 2. So this is our correct answer. Clear?